Well, I think we'll go ahead and get started and just remind those of you who are attending that this session will be recorded. And if you have any questions, you can put your questions there in the chat box and we'll make sure that we come back and circle around and answer those. I know that some of you have had an opportunity to review other recordings that we've had. And if you're just joining, and I'll remind people as they join in later today, if there are particular topics that you're interested in, for example, what does the professional development look like? Or what is the experience like for one of our partner school districts who's implementing elementary computer science? You can go back and look at some of those past recordings and look at the guest speakers, and they will have some varying topics that they've addressed that might be of interest to you. So please take a look at that. So we'll go ahead and get started, and I want to introduce our panel for today. So I'm Clark Merkley, the Executive Director of BootUp Professional Development. We also have with us Jack Ologist, who is the Senior Program Manager for Amazon Future Engineer, and we'll hear from Jack here in a few minutes. And then we are also pleased to have Dr. Jared O'Leary, our Director of Curriculum and Professional Development at BootUp, and he'll be talking a little bit about some of the philosophical underpinnings of our work and some of the academic research behind our approach to elementary computer science. And I apologize, I do have hay fever. It's not COVID, but you know, if I have to cough and clear my throat, I'm still dealing with tree and pollen allergies here today. So just a quick update. As all of you know, we're still living through this worldwide pandemic, and it's caused a disruption in education. A lot of things have moved online, and a lot of administrators are no longer working in their offices. So we've extended indefinitely the deadline for applying for the Amazon Future Engineer BootUp sponsorship that we'll be talking about today. And we've actually got our first group of applicants that we'll start reviewing today. We have a panel of expert reviewers that will be reviewing those applications, and we'll continue to accept applications and review them on a rolling basis going forward. So if it's not too late to get an application in, and we would encourage you to do so and bring this wonderful opportunity to your district for elementary teachers and students. And we do ask, if you go to the BootUp website and look at the Apply Now button, you'll notice that there is an intent to apply survey. So if you don't have time to complete the full application now, you can click on that intent to apply and click on that short survey and let us know so that we can keep you updated about any future developments as we review and approve those applications. And a lot of your questions too can be answered by going to that the AFE BootUp SM Apply link there on this slide or at our website. So a little bit about BootUp Professional Development. We are a nonprofit that works nationally with partner school districts to implement elementary computer science initiatives. And what we've done up to this point in our history is full district implementations, meaning that the district administration, building level principals, and others are on board to make sure that teachers who are receiving the professional learning from us have the institutional support that they need to be successful as they learn about computer science and coding and computational thinking, and as they begin to implement that in their classrooms. So the BootUp offering is not only providing professional development opportunities for the teachers of coding, and those could be classroom teachers or specialists or media techs or librarians. We've kind of done the whole range of possible teachers of coding. And we also develop in each district a district level instructional coach. And in larger districts, there may be more than one or several. And that instructional coach will be the one that assumes the responsibility for future training of new teachers and replacement teachers. In addition to the professional development, when we come on site, we also like to do some other things like model teaching, where our facilitator will get up in front of a class of of one of the teacher's actual students to show how a model or how a lesson is facilitated in computer science. And that helps the teachers take that, what they're learning in professional development, and apply it more directly to actual day-to-day practice. We also provide curriculum support, and it's, as Jared will describe a little bit later on, very thoughtfully developed and fun and engaging for elementary students. And that's available free on our website and will continue to be free. That's a commitment we made as a nonprofit a long time ago, is to make our curriculum resources available to students and teachers that would be interested in using them. We also help each district develop a professional learning community of the coding teachers and provide additional coaching and support when we're not physically present in the district. And by the way, in case districts are looking at extended learning from home or remote opportunities, we do have the capability of doing our professional development online, even though we prefer the immediate feedback and modification and adjustment that comes from doing it in person. So we were excited to announce several months ago our partnership with Amazon Future Engineer to provide computer science support to elementary schools and districts across the country. And what we love about this partnership is Amazon Future Engineer's commitment to reach those districts where they've previously been underserved or they have high need. And we'll have Jack talk about that here in a second. But our whole goal in delivering our services under this sponsorship is to make sure that teachers can be confident and self-efficacious in their computer science instruction. And that means that they feel very comfortable doing it. They can draw from a variety of resources, and perhaps even most importantly, integrate these principles across the curriculum in language arts, mathematics, art, science, music, whatever they're teaching, using coding as another form of expression. So I'll turn a few minutes over to Jack Ologist from Amazon Future Engineer and have her talk about their exciting initiatives.
Thanks so much, Clark. And I do see Amanda has her hand raised. I don't know if, Amanda, if you had a question that you wanted addressed.
Okay, she looks like she lowered her hand, so you're
okay. Sounds good. Well, thanks, Clark. And as you mentioned, I'm Jack Ologist, and I lead our elementary programs for Amazon Future Engineer. So our overall Amazon Future Engineer program launched back in the fall of 2018, and we are a childhood to career program and really aim to increase accessibility of computer science education to students, as Clark mentioned, especially those from underserved and underrepresented communities across the country. So within the K through 12 space, we really focus on providing teachers with computer science education, professional development, as well as the curriculum and courses to districts and schools across the US. In the college space, we provide 100 students each year with $40,000 scholarships, and then an automatic internship at Amazon after their freshman year of college. So as we build out our programs, we really try and find ways to provide opportunities for students to get inspired in their elementary years and then build those 21st century skills, and then have the avenues available to them to persist in computer science through to a career in the field if that's what they choose to do. So we really want students to have those resources available to them at every step of the way to help them build their best futures, whatever, like I said, they choose for that to be. We're super excited to partner with BootUp on this initiative and really hope that we can work with all of you in the future.
Thanks, Jack. And we greatly appreciate this sponsorship because it allows us to bring exciting elementary computer science initiatives to parts of the country and to districts that may not otherwise have that opportunity. So thank you, Jack. And Jack will stay on board for some questions if you have them a little bit later on. And since we have a fairly small group with us today, we'll open it up and allow anyone who has questions or comments to participate. So I want to give you just a really quick background into computer science and coding at the elementary level. A lot of times what you'll hear if you listen to the major media outlets or read stories, they talk about the gap in the IT field or in computer science or artificial intelligence or other applications. When we're talking about elementary students, we're not focused so much on the future careers that they might be preparing themselves for, but rather focused on providing them with a literacy, another form of expression that they can use. So we teach students how to read and write, not because they're all going to grow up and be novelists or journalists, but because that's a critical literacy they need to have to be successful in life and as a citizen in the future. And the same thing with mathematics. All students learn how to, and I apologize, I'm working from home, and so that's my doorbell going off. I do apologize for that, and I'm not going to be able to answer it. But giving them the ability to code is another form of expression, another way that they can get their creativity out, share their own voice. And so when they learn to code, they can organize and express and share their ideas in new ways. And I'll just share one brief example. Very often what we'll have teachers do as they go through professional development is they will be learning how to do coding or computer science, but we'll immediately ask, what are you teaching next week? And how can you use this? And teachers immediately begin to see applications into language arts. And so, for example, instead of the traditional book report after reading a new book, teachers are able to give students the opportunity to do a coding project. And the teachers can assess all the things they would normally assess, like spelling and grammar and usage, and did they understand the plot and the characters, but doing it in a very creative and engaging way with this new literacy that they have. And we know from our experience in elementary schools all around the country, we've reached almost 170,000 students now. And with the Amazon partnership, we anticipate probably a year from now, that might be close to 1 million elementary students that are learning more about coding and computational thinking. But it has the potential to be really transformative in the lives of our students. It teaches algorithms, or that set of instructions that a computer uses to operate. And students learn, really powerful skills in taking control over their environment. I had a person I was talking to the other day, and they shared a really funny story with me. They were in a kindergarten classroom, and they were watching the students doing a project in Scratch Junior, which is a free platform that MIT has created. And this teacher walked up to this computer, or the kindergarten student on the computer, and the kindergarten student said, "Pooters aren't that smart." And the teacher said, "Well, what do you mean, computers aren't that smart?" "Well, they just do what I tell them to do, so pooters aren't that smart." And I thought that was a great story when it shows how even a kindergarten student learns to have control over her or his environment with coding. They get to incorporate design concepts. So just as an architect, as she sits down to draft plans for a new building, has to think about function and form and all of the mechanical operations of a building before she starts sketching. Students do the same thing with their computer science projects. They're thinking about what they want it to be and what characters they want to incorporate, what music or what sounds or other things that they want to do. And this really encourages their creativity. It enhances a making mindset. So they're not only consuming code, which they do all the time on computers and devices, but they're creating their own code and making connections with the critical E in STEM, that engineering component, using the T or the technical to make those connections. And what we find in a really great coding classroom, it's a buzz. It's a place that is just lots of conversations going on as students share their projects with each other and with their teacher, and they're excited about what they're doing. And it really is exciting to see how students get engaged. So why do we think it's important to teach computer science at the elementary school level? First and foremost, it really prepares young students for their future. They are going to be working in careers or in areas where they may not be doing software development or IT work, but they may be communicating with those that are doing that work. And to the extent they can understand the nature of the code that's behind the things that they're doing, because everything that they will touch, practically every device, every appliance, every automobile, every financial transaction they're involved with has code behind it. And so they learn to understand that. When they start young, like this young girl in this picture here, I think this is a kindergartner or first grade classroom because she's doing a project in Scratch Junior. They're much less intimidated. In fact, the most exciting thing that I get to see is walking into a classroom full of kindergartners who are learning to code, running over to the cart to grab their iPads and then back to the floor to start working on their projects. And they find ways that they can express their own ideas and things about their own individual life and culture, things that are important to them. So this picture, the girl is actually placed her own face in an astronaut's suit. And really, they start to believe in, their own capacity to be something great in the future. And it's very inspiring. So we like to build that confidence and that ability early on so that when they reach junior high or high school and they're offered an elective course, they're much more likely to take it because they have built confidence over many years in elementary school. And we've already talked about, our approach to teaching coding as a new language or literacy, not as a separate class or as a job skill or a technical skill, but really as another form of expression. And what we find is that it really develops a growth mindset and persistence in these students. One of the essential parts of learning to code is the concept of debugging, which is the program never works the way that you originally design it and the way that you originally envision it. And so it takes tweaking and changing and adjusting to make it work. And students learn through that process to be persistent until the program is working the way that they want it to do. And it gets really exciting when they make those same connections in other subjects like math, when they realize that math problems are another form of computational thinking or algorithmic thinking, and they hang in there and persist rather than just giving up. So I want to turn some time now over to Dr. Jared O'Leary, who's going to talk to us about our curriculum and our approach and some of the academic basis for what we're doing. So Jared, I'll turn the time over to you.
Thanks, Clark. So the first thing that I want to point out is I previously did a webinar that was on March 4th, and that was recorded and shared on our website. In that particular discussion, I kind of give an overview of the curriculum resources that are available 100% for free, as well as a preview of what our PD actually looks like. So today I'm going to talk a little bit more about some of the philosophies kind of behind our approach. So next slide. So rather than thinking of only solving puzzles with code, we really want kids and adults to use code to create projects that are individually meaningful and interesting, as Clark had mentioned. So to do so, we use project-based learning with the free platforms Scratch Junior, which is recommended for K2 or pre-K2, and for Scratch, which is used in grades 3 all the way up to like college. So project-based learning can occur along a continuum of fixed to open projects. And next slide. So if we were to kind of think of project-based learning in this continuum as like an art walk, on the left side, we have our fixed projects where everyone creates the same project. So if we're in an art class, on the image on the left, everybody created a tree and they all used the same or similar colors in a similar order. So like from the sun, it's going from like yellow to orange to red, and all having like sparkle somewhere on there, et cetera, et cetera. So they're all creating a tree through the medium of painting. Now, in coding, as an example, we might have a fixed project where everyone is creating a game, let's say with a player sprite and maybe 3 enemies, as well as conditional statements that kind of determine whether the player wins or loses, and maybe a variable that keeps track of a score. So that's an example of like what a fixed project might look like for coding. Now, on the other end of the continuum, we have open projects. So on the image on the right, if we're thinking of art walk, we might think of like different art mediums. So maybe somebody's going to sculpt something. Maybe somebody's going to draw something or paint. Or instead of everybody creating a tree, if we're all painting, maybe we're all going to paint something that's different. Somebody might paint their dog or a cow or a building or whatever. If we think of this in relation to coding, we might begin with questions such as, can you create a school-appropriate project that helps someone? Or maybe something that solves a problem you see in the world, or reminds you of a special like story or event, a place, whatever. So on the open-ended projects, there might be very little to no explicit criteria mandated by a teacher, facilitator, as the projects are supposed to be kind of proposed by the kids who create them, and they have a lot of flexibility on them. So next slide. So somewhere in the middle, there's what I call like flexible projects, which has kind of aspects of both being fixed and open in terms of their design. Now, what I want to say and why I bring up this continuum is our projects in our free curriculum use a combination of all three approaches. So some swing more to the left side towards fixed, some are more in the middle and are flexible, and some are more open-ended. So this gives a range of creativity and resources that kind of help kids create a variety of projects. Next slide. So in addition to the project continuum in terms of PBL, there's also an implementation continuum. So our curriculum takes into account this full range of potential implementation. So on the left, we have sequential. So maybe start with project 1, and when you finish that, go to project 2, then to 3. You have that option. You can go through all 40 of the Scratch projects in order if you'd like to. That works great. But on the other end of the project continuum, we have what's called Rhizomatic Learning. So this is a philosophy proposed by Deleuze and Guattari, an educational philosophy. So if you see that image of a network with all those different nodes on there, if you think of every single node on there as like a different CS concept or practice or standard or whatever, a kid could pick any one of those nodes, start there, and head in any direction. And if you have a class of 30 kids, they could all start on 30 different nodes and head to 30 different directions. So that's kind of an idea behind Rhizomatic Learning. Now, the way we support Rhizomatic Learning is through the step-by-step videos and visual guides that I highlighted in the webinar that we did on March 4th, which again, you can watch that recording. And what this allows kids to do is they could pick any project and go in any order that they'd like to. And it allows them to really focus on their interest driving their own learning through autonomy. Now, again, somewhere in the middle, we kind of have a balance between the two. So what you could do is say, hey, here are 3 projects. Pick one of them that sounds interesting. And when you finish them, here's another set of 3 projects that you can work on. So in our PD, we kind of talk about those different approaches. And one of the reasons that we really like to focus on this creativity side of things and allow for this autonomy to encourage kids to create something that's interesting to them is because we really want to make sure that we emphasize that not everyone is going to be interested in a career in CS, and kids can use coding for fun or for leisure. Like I proposed to my wife by modding a video game. So Jerry had mentioned learning Java. I learned Java so that way I could propose to my wife. So like that's an example of how you could use this for fun. Next slide. So we emphasize that in our PD, really try and get the teachers to understand that, yes, while there's a lot of opportunities for learning CS for careers, you can also do it for enjoyment. And so speaking of our PD, one of the things we really like to kind of model throughout all of our sessions are characteristics borrowed from informal learning spaces known as Affinity Spaces. So the 12 characteristics that are on the screen are modeled in various ways kind of throughout our PD sessions over the course of a couple of years. And in particular, we kind of unpack and discuss these in detail in year 2, after teachers have had experience with them, because we don't want to just overload people with all these informal learning concepts without actually having some context for it. Next slide. In addition, throughout each of our PDs, we also like to focus on developing PLCs, so professional learning communities, within and across the districts that we work with. So for example, after each set of projects modeled within a PD session, we engage in a group discussion on how the concepts, practices, and standards from the projects might integrate with other subject areas. So we then share our integration ideas on a discussion forum that teachers from other school districts are able to read and contribute to. So the overall point of this is the approach is it develops a PLC and encourages collaboration both within and across school districts. And the approach of collaboratively developing integration lessons encourages long-term sustainability by teaching a person to fish rather than providing prepackaged fish. In other words, rather than just handing a set of integration lessons, we want to find ways that teachers can infinitely create their own lessons that integrate in their own subject areas and standards relevant to that district. And next slide. That was a very quick introduction that kind of provides some background on some of the curricula and PD philosophies that inform our approach. If you are interested in learning more about it, again, check out the webinar on March 4th in particular, where I kind of give a preview of that, as well as our other previous webinars that unpacks different aspects of what we are offering. And then you can also listen to more of the philosophies and approaches that kind of guide what we do by checking out our podcast. So this podcast explores research, experiences, perspectives, etc. on CS education. And that's it from my end.
All right, thanks, Jared. As you can tell, and also thank you for letting us geek out on educational philosophies. This is something that we all have a passion for. Not everyone does, but we certainly like to make sure that what we offer to our partner school districts is based on the latest in academic research, and also really encourages, rather than a boxed curriculum, which is sort of the far end of the less creative spectrum, really getting kids engaged in creating their own things. And Jared's a master at that. If you take a look at the curriculum resources we have, people say, well, how who is this person that's coming up with these amazing ideas? Because kids love these things. And Jared's a former elementary school teacher and has a real great sense for what kids like, and also exploring the range of those interests. So thanks again, Jared. A quick statement about our application process. I'm not going to play the little video in this that goes along with this presentation, but I would encourage you to go to the application page. It's a very simple process. You register, create a username and password so that you can get back into your application. The application form itself is relatively straightforward and easy. In fact, far easier than most grant applications you've ever completed. And does ask some demographic, some demographic questions about the district and its characteristics, and also asks in some open text boxes for the district to describe what their plan is for implementation and some of the approaches they're taking. So for example, in very large districts, what we're seeing is staged rollouts, or try it with a group of schools first and then expand. And yet other very large districts are doing this district-wide. So it really depends on what your district wants to accomplish. There's no right or wrong answer to that. The more completely you can describe what it is you have in mind within the limitations of the character count, it would be great. And there is a place in there. We want you to make sure that your superintendent is signing off on this. And there's a form that you can automatically generate to have the superintendent sign off to support the initiative. And I'll go to the next slide because it has information about how to contact us if you have any questions, the web address for the application itself. And then what I'm going to do now is, since we have just a few of us here today, I'm going to open it up to everyone. So I have unmuted everyone if you'd like to be unmuted, and you can ask any questions or make any comments that you would like to make. And Jerry, thanks for joining us. I noticed that you had joined us since we got started. And just so you know, this session is being recorded, and you can go back and listen to it later or share it with colleagues if you would like. And maybe if you have a question or comment, you want to raise your hand and ask either of Jared or of Jack or me, or if you want to drop it in the chat function, either way. Okay. So I won't beg for any questions, but here we go. It looks like we've got some coming up in the chat. Oh, okay. Abby's also on. Any questions that came up in the chat, Abby, that we need to address?
No, I don't think so.
Okay. Well, just to let everyone know, we are available if should you have any questions or should you wish to learn more about BootUp or Amazon Future Engineer, you can go to the BootUp website, and we not only have all of the free curriculum resources that Jared was talking about that are available there for your review. We also have a page for at-home resources during COVID. And if you go to the Amazon Future Engineer page, there's some additional resources there for teachers who are trying to find creative lessons or opportunities to help their students while they're still learning at home. And we would encourage you to take a look at those resources and share those with your colleagues as well. So if anyone has any questions and you want to reach out to any one of us individually, please feel free to do so, especially as you start working through an application on behalf of your district. We would be more than happy to help you with that process and review your application as it comes in. Jack, any other parting comments?
No, just thank you so much for taking the time to join today, and really hoping to see your applications come through.
Great, and thanks again, Jared, for sharing. What I think, it's a little geeky, but it really is exciting stuff about why we do what we do and why it's so important. And you see this. I love this last picture because this is one of our elementary classrooms. And you just see how excited these kids get when they get a chance to express themselves through coding and other projects. And that's really what it's all about, is the joy of creation and the joy of engagement. So thanks for joining us today. I hope everyone has a wonderful rest of your day and a great weekend, and stay healthy and safe, and be in touch if you have any questions.
Thanks, Clark.
Thank you.
Thanks.